Introduction to LLMs and GenAI Frameworks, Understanding Large Language Models and Generative AI. Welcome to our in-depth introduction to large language models, LLMs, and generative AI frameworks. In this video, we explore the evolution of AI from traditional machine learning to the cutting-edge world of LLMs. We'll break down key concepts, discuss the components of a generative AI project, and introduce you to the most popular frameworks like Llama Index, LangChain, and Crew AI. What's inside? Evolution of AI, journey from machine learning to large language models. Introduction to LLMs, understanding the foundation of modern AI. Generative AI Project Components, key elements that make up a successful GenAI project. Exploring frameworks, a deep dive into Llama Index, LangChain, Crew AI, and more. Sample project, a walkthrough of a real-world project to see these frameworks in action. Whether you're new to AI or looking to deepen your knowledge, this video is packed with insights and practical examples to help you navigate the exciting world of generative AI. Don't forget to like, comment, and subscribe for more AI content. AI, machine learning, generative AI, LLM.
Today's session is about LLM, where LLM and its framework LangChain. So yeah, so where like what is basically LLM and like what are the topics we are going to cover in this session. The first one is what is LLM. Second is how it evolved and the type of LLM frameworks, and then our main framework which we are going to discuss in this session is a LangChain. So first one is like what is LLM? LLM stands for the large language model, which can generate human-like text. For instance, using GPT in its various form for years. So we can also say like LLM is also a foundational model, which will pre-trained on large amount of unlabeled and the self-supervised data. And what is about foundational and pre-trained means here? It's about model learns from pattern that produce generalizable and adaptable output. Then what are the key characteristics of the LLMs, such as about its scale? Like LLMs have a vast number of parameters. If we focused on its parameter, then we are talking like potential like models can be a, we can say if a large model, it can be a 10 of gigabyte in size and trained on enormous amount of text data, which we potentially call the petabytes of data here. Or if we can say that if the we are providing a text file having a 1 GB of a text file, the size of the file is a 1 GB, so having a 178 billion words, so it's like a biggest model when it comes to a parameter count. More parameter model has, the more complex it can be. So for example, it's like on the pre-training and the fine tuning of the model, which will having like the second characteristic as I explained on the like on the parameters about like how we are going to train of such a large file it LLMs having. And on performing a like on third characteristics, if we see, it's a versatility, which can perform various NLP tasks such as text generation, translation, summarization, sentiment analysis, and in more, if you can say that like a question answering of the prompt and for the queries, if we say. And yeah, so next is like how LLM work. LLM works on the, if we divide like a just this structure, like first one is data. Just before, just a while ago, we talked about how the text file we are passing into it. Like we can also passing in like upcoming the images also we are using in a language models, or the videos we are also using. So it's like a data we are talking here. Then apart from data, we have architecture. Here, architecture means enables the model to handle the sequence of data, and transformer are the design to understand the context of each word in a sentence, which will basically considering it in relation to every other word. Then training. Training here is during training the model, it will learn to predict the next word in a sentence. For instance, if we say if we are providing a text file in a data, then if we look into the architecture where model has to handle the sequence of data, and then in transformer, if in that context each word, like if we say the sky is dash, then it is continue going on the comparing the different words in a file or in a the data file which we passed on it. Then first if we see that the transformer matching trying to predict the relation among like understanding the word. And then during training, if what it is like what it will is going to do, it's like the sky is bug. If then continuously on iteration and iteration, it will automatically find the okay, the sky is a blue. So large language model also works on the how many times we iterate on it. And if we see the evolution of the like large language model, how it evolves, like to get the better idea about the like what is LLM, how it comes on the picture, and like so it will give us a basically a clear understanding of the training and tuning of the model. So on the 1950s and the 1990s, first we have the NLP and the statistical model, where basically we are training the model with a like a human is usually doing all the tasks which currently machine is going are doing currently. Then on 2000 it evolves to a neural network and embedding. Then neural network and embedding means it start from a RNN and LSTM, which is then again on 2010 it more reform on reinforcement learnings. Then on 2017 we are introduced with transformers and the self-attend machine. Then 2018 we have bidirectional enforcement training model, which will basically do the left side and the right side, both the side of the transformer, to say the architecture learning from it. Then on from 2018, we have the series of GPTs and large scale pre-training models. And on 2020s, we are continuous scaling and innovating of this LLMs model, which are such as GPT-3, GPT 4.5, or we can say that Llama Index, or we can say on the Palm algorithms, and the many more are like on the verge of okay, then the type of LLMs framework. There are the different types of LLM frameworks in the series. Like LLMs have many frameworks, but currently in this session we are seeing this three LLMs framework, and we basically elongate do discussion on LangChain. So the first is Hugging Face Transformer, which is a comprehensive library that provides a pre-trained transformer model for various NLP tasks, which basically supporting seamless integration with PyTorch, TensorFlow for model training, fine-tuning, and deployment. Then we have OpenAI GPT-3, which is a which will grant access to OpenAI, which is the art of the GPT-3 models, enabling developers to integrate advanced text generation, understanding completion capabilities into their application. Then we have T5 text to text transformer, a framework which is developed by Google that reformulates all NLP tasks into a unified text to text format. Then okay, then our main focus is on current session is on LangChain. In the LangChain, we are going to discuss about how the LangChain work, or the what were the applications of the LangChain, and what were the like benefit of the using the LangChain, and what was the need, like what is the need of current on the current time, what is the requirement, and where the LangChain lies on the demand of the LangChain, basically, if we say. So yeah, all this we are going to see about LangChain here. And at the last we also see the basic libraries, basic coding, like how we can give a LangChain model to a company, or like basic example, and at the last we are going to see on it. So yeah, okay, the first is LangChain. Is like LangChain is a open source model which is it's like a connecting a language model together. Language, LangChain stand for, if we divide the lang means language, chain it's like connecting all the modules together, such as a tool using existing AI model. And LangChain is also bridging the gap in LLMs, because if we see, like we have to use different language models for different needs, but LangChain overcomes the this we can say that con of the LLM. It's like it's using the it's like a API it's using to connecting, like to do work in a single model. We don't require for each function we don't require a different model. So LLM LangChain is overcoming that drawback of the basic models. Yeah. So yeah, it's like if we say like we have a lot of LLMs available today, they have their capabilities and preferability. If I prefer to use one LLM to interpret some user in my business application, and a whole other LLM to author a response to those queries, in that scenario is as exactly what LLM caters to. Like LangChain is an open source or framework which develop where like the development of application that uses LLMs, and it comes in both Python as well as JavaScript libraries. It's basically a generic interface for nearly any LLMs. We have centralized environment to build your LLM application, or we can integrate on it. Then LLMs have like a LangChain have the like a different application. If we see on, like it's a chatbot summarization, question answering, data augmentation, and virtual agent. Okay, so next, if we see on the basically it's a LangChain, and it's connecting single. We are using the single model for doing the different app, like different types of job using the single model. Then it's if we see here it's the first one is if we see it's like a prompt. So in prompt it's like a instructions, it's like template the class in LangChain, formalize the composite of without the need to manually hard code context. If we say like the person is passing the some query or the hardcode text, if we say, then LangChain is basically storing the data on its vector store. Then first one is like document loader, then again we jump on the vector store. Vector store it's like basically a storage of the, we say, the data or the files, if we say, on it. Then if we passing the some prompt or the some template, it formalizing, it's searching on it and giving back us the result in it. And then we have on it LLMs also, where we need API keys for that. Then we have also in it applications, uh, we can say that combining the, okay, then I will show like what were the like applications model we have, like code of it. Any doubt till here? Okay, then I'm going to share the Python code. Okay, so this is how what were all the application we are going to work here. In LangChain, I am using here. First, we need to install the LangChain and its Open AI model, or we can so here we can use OpenAI model as well, but OpenAI ChatGPT model is like a paid one. So I use the group model, which is a free API we can use along with it on LangChain. Yeah, so we install on it. We install this model. Then after installation of the basic chat group here, then yeah, we are importing operating system here. Then from LangChain chains, we are importing LLM chain model, as I have showed in the last PPT, like how LangChain is connecting all these things in a single way. So what all are requirement we are just importing here. The first one is LLM chain we import. Second is prompt template, as I showed in there, we import. And then chat group we import. Chat group is basically the main one we are using here, because chat group is another API we are using, which is a free version. And chatgroup, it's like a open source model. It's totally free and almost a real-time application which is working on LPU. LPU here stand for language processing unit. So it's like yeah. Then and then if we say we are using the group API key, which like you can find on your system as well. So it's like a I use this key. Then if then on passing the model, we need to mention the temperature here and the model name. So model name is here stand for the chat group. What is chat group? Like stand model we are going to use. Basically chat group has three models, so we are using this one. And here temperature stand here, it means like it's an underlying factor which is influencing the output. It's determined, basically the output will be a predictable or creative. Temperature here stand for, because basically what is LLM, it's like using the predicting, basically like we are passing on the queries, on searching it giving us the result. So how can we say that the result is more like on predictable side or more on creative side or more on it exploring? So basically we set the temperature here at the what in what phase we want it. So if the high the temperature, it explore beyond it, we can say that result, or like sorry, the thing, like we can say the original thing, which like it will explore more on it context. Basically if the higher the temperature, it will explore more on it predict apart from the actual phase, it will predict more on um, predictable or creative side, basically. Yeah, so if we run on it, it might take a little bit time extra. um, I will sometimes this again it's showing error. Okay, one second, I need to run this first. basically to work on like continuation, we have to like run all the things together. Like yeah, then it's run. Then again we'll go on to here. Yeah, it's set. Then again it's like the basically environment we are setting here. Then if we have come on to this, then we basically see all these functions. So like all this we can see the area functions one by one. So first one is prompt template we are seeing here. On prompt template we are passing the input variable as cuisine, and in template I want to open a restaurant for this cuisine food, suggest some fancy name for this. So basically I am passing a template for this cuisine name, where I can like change our cuisine such as Italian, or we can come on to a Indian or the Mexican. So yeah, if I'm running on it, it basically give us some fancy name for a restaurant. Yeah, okay, so see it's like giving me some fancy names, like how about this El Songo di Cucina Italiana, and which means the dream of Italian cuisine. The name suggests a high and elegant drinking. So basically it's giving us the name here, Italian name. If we I can prompt it like change onto and give me some Mexican cuisine name. You can see the result as well. Yeah. Yeah, okay. We can see here, like for Mexican, it is generating the Kyoto de Alba, which means the name suggests a sophisticated and unscalable dining experience. Okay, so basically we are using here the prompt template. And again, if we come on the second one, it's like on a chain. Like, what about the restaurant name? Here it suggests there's some fancy name for this. And then again, like food items, like what menu should be there, like I need about the, okay, the name of the restaurant is okay, fine, the first step we done. Then the second is like what item should be in the menu, and what should I do on that. Then it basically give us the result here. We can see here. Okay, yeah. So yeah, as I pass the cuisine name here as an Indian cuisine, I want a food item chain here. So yeah, it's passing the some first it is suggesting some menu item for exotic saffron, which is a Indian restaurant name. It's suggested. Then the name of the appetizer, it's suggesting soup, salad, like all the menu. The system prompt is generating on its own. Then if we change on the name here, it's we go on to do again Mexican here. Then we will see what it is generating. Yeah, you can see it giving us the whole detail of the things, like menu with details of the of item, or we can see that the dish details in that. Then it's like a sequential chain. We follow the API here. It's like a function sequential chain. And next is like on the memory, like whether it's basically the LLM has one drawback about it memory function. So we are overcoming this memory function in LangChain model. Here we are seeing checking on it, like whether it's giving us the old name or not, what he suggested in our in that Mexican food chain. So yeah, if we see the name were the same here, if we see on the Indian name also, where I have done here. So yeah, it's generating the exotic set from the same name about it's generated. Basically, if you go and if you check in the chat GPT, it will not going to give us the previous result. So this is the LangChain overcoming on it. And so this is the like I just like showed you the four of five functions in it. Then like we can say further, if we see if there's a in memory, there is a conventional buffer memory, conventional sequential buffer memory. We have like a lot of types of memory function in there. And also we have agent, like LangChain also work on it Wikipedia API also, like where you search for, if you just take for example, for instance, if you pass the Elon Musk details on it, then what LangChain will do, it will we need to pass about the Wikipedia's API key. Then it will go on and research about the Elon Musk, and it will generate that text for the like Elon Musk detail. It will basically provide you the Elon Musk detail. So okay, so this is the like all the function we can use continuously. Like there's a many functions in LangChain we can use on. So basically now the question is like what, like how LangChain is like using in the industries, like what is the requirement of using LangChain in the industry. So yeah, LangChain is basically a, like if you have the question like how why there's a requirement of LangChain, if we have OpenAI, we have a chat GPT, if we have many chatbots model, then what is the need of LangChain. So the need of the LangChain is like a, if I have my own industry, I'm going to run my own company, then obviously ChatGPT don't know about the my storage, my detail, every bit details of the like what is the employee detail, what like how much how much work is done, and like where the how many projects are on pending, everything a bit to bit detail. No ChatGPT is going to work for you. So LangChain basically come into the picture where we are going to design our chatbot, which will store our information, our like work information, our company information on it. If we go on passing the okay, show me how many employees were attending on time, or how many employees were did delay, how many leaves were there, or how many leaves are left, and like bit to bit details like about this project, explain me like about this project, what how much like processing details, like finishing deadlines and everything, when the next meeting will be there. Like bit to bit details is are going to be present in our chat gpt models. So here the langchain models are come into the role of the industry. So basically this is a requirement of the langchain model we can use to develop for our industries. Yeah, this is all from my side.